Okay, peeps. This is a quick review video that may hopefully let us know for your quiz if you want to know what's on it, because we're not covering all of Chapter 7. This is it. We are done with calculus after this quiz. So we're only doing the first half of Chapter 7 because that's what's in that's what's on the AP test. Everything else is not. So that's why we're looking at that. And so here's a little good review for the quiz. So it says here, find the displacement and total distance for a particle moving on the curve v, so that lets us know its velocity on the interval -2 to 4. So I can't remember what parts of this are calculator or non-calculator. We kind of discover that as we go through, but what I might do is I might go ahead and just factor this, right? I see that this factors into t minus 2, t minus 1. So I know that it crosses at 2, 1, and 2. And it's a parabola that opens upward. So my guess is that it looks, something like this, but we could double check, verify. If I plug in -2, -2 squared is 4, plus 6 is 10, plus 2 is 12. Yeah, so at -2, it's way up here. Comes down, dips below, and at 4, 16 minus 12 plus 2 is 4 plus 2 is 6. So it's back up here. So what's the difference between displacement and total distance again? Well, displacement is just the integral from 2 to 4 of this guy, right? We could do this without a calculator. 1/3 t cubed minus 3/2 t squared plus 2t. I mean, it's gross, but we can do it, right? I don't know if I'd want to do total distance without a calculator, but we can still do it. 64/3. 4 squared is 16 divided by 2 is 8 minus 24 plus 8. Subtract out what you get when you plug in -2, which is -8/3 minus 6 minus 4. So this is going to be plus 8/3 plus 10. This is going to be 64/3, and that's minus 16. So this is -6. 8/3 and 64/3. 72/3, which I believe is divisible by 3, right? It's 24, so 24 minus 6 is 18. So the area under this curve is 18, and that is the displacement. Right? And actually, before we even do total distance, let's jump down to this question. If the particle's initial position is 7, where is it now? Well, it's just 7 plus 18, which is 25. That's where it would be now. To find total distance, I might not actually do the whole thing, but to find total distance, we got to treat this area as positive, right? This area is positive. And this little area, we got to make it positive, right? That little guy right there. So you would have to find the integral from -2 to 1 of this function. Find the integral from 1 to 2 of this function and make it positive, right? And you have to find the integral from 2 to 4 and add all of those together. I don't think we should do that by hand. That'd be a little bit much, right? But that's the idea of those types of questions, right? Would you know when this thing is moving left, right, when it stops? It's moving to the left when it's below the axis, so between 1 and 2. And honestly, I probably shouldn't have used negatives, though, if we're going to talk about that, so probably why I didn't. But it's moving to the right when it's in the positives, right? Let's cross this off because we answered this last time, but this is another good question, but I kind of have this in here instead of saying find it's total distance. I don't say that, so let's find displacement in this. So 2 cosine starts at 2, and by 2 pi it would be done. So by pi it's just at its bottom point, right? So this thing looks something like this. Well, what is the displacement? Well, we can probably predict that, right? The displacement is going to have those two cancel out, and we're just going to get 0, right? But if we want to double check it, we could just take the integral from 0 to pi. I'm so sorry about all this language, of course. Friends, that is not me. So then you go backwards, and that would be 2 sine t, right? From 0 to pi. Where you plug in pi and 0, you get 0. So that's why displacement is 0, but we could eyeball that and know that. So if we take a look here, what else maybe do we need to know? We want to know its initial position, or find its position at 3 pi over 2 if its initial position is here. I think the easiest way to do that, we could do it with some displacement ideas, but I think the easiest way to do that is say, oh, well, we can go backwards to the position function, right? And we can say, we have 2 sine t, right, is what we said is backwards from 2 cosine t plus c. And now I plug in 0 and 3, but when I plug in 0 and 3, times 0 is 0, so this whole thing goes to 0 plus c. So s of t equals 2 sine t plus 3. And then you just plug in 3 pi over 2. Oh, sorry, plus 3. We just plug in 3 pi over 2, and we'll get what we need. So 3 pi over 2 is 270. Sine of 270 is -1. It'll be -2 plus 3. So right now, the position would be at 1. So good to go over a couple of those things. What else is on your quiz? Of course. It says the base of a solid is a region between the line y equals 4, 1, 2, 3, 4, and the parabola y equals x squared. Well, we've seen a lot of that, right? So it's going to cross here and here at -2, 4 and a 2, 4. So this right here is the base of a solid. So honestly, I feel like what I should do is probably just kind of get rid of a little bit of this stuff here. And then just erase all of this now, right? So this is the base of a solid. The cross sections perpendicular to the x-axis are semicircles. So this is the type of the problem in the book where they might have drawn it for you, but we can do it. It's like saying that all the stuff that comes off of this thing is a semicircle. So that's really interesting there. So it wants to know what the volume of this thing is. Well, first thing to discover is, well, what's the area of a cross section? We got to draw it. We just drew it. What's the area of a cross section? Well, it's a semicircle. What's the area of a semicircle? Well, it's pi r squared, but we got to divide it by 2 this time. Didn't do a lot of semicircles yet. We need the bounds, but the bounds, well, this is interesting. The bounds are, if we're perpendicular to the x-axis, that means we're adding up along the x-axis, so we're going this way. So this isn't y integration. This is x integration because our radiuses can be calculated using functions in terms of that as well, right? This is going to end up being a radius. So our bounds should be from -2 to 2. I have to put my 1 in there. There we go. And then we decided that the formula is pi r squared over 2. We got to figure out what that radius is, right? Because we need the radius to be something in terms of x. Well, this is pretty tough. How would we find the diameter, maybe? That's the distance between the two. Well, that's just going to be 4 minus x squared, right? Because that is the distance between the top line and the parabola, right? But if we only want half of that, right, we just want half of that, then we obviously just have to cut that in half. So what's crazy is this is the integral from -2 to 2 pi, and then in parentheses is 4 minus x squared over 2. squared all over 2, because this is what a radius is. That was a tricky one. Ooh, probably good that we did that one. I'm trying to think if I actually want to do this one in my head. I think the answer to that is probably no, but what's a little practice? I'm going to pull out the pi over 2. So I'm pulling out this guy just so I can deal with what's squared, right? So -2 to 2. And then I'm going to square the top and the bottom. Square the bottom, get 4. Square the top, I got to FOIL it. 16 minus 8x squared plus x to the 4th. Now I'm going to pull out the 4 as well on the bottom. So I'm going to have pi over 8, -2 to 2. And then I'm going to put in order x to the 4th minus 8x squared plus 16. And now I could go back 1/5 x to the 5th minus 8/3 x cubed plus 16x, all from 2 to -2. I have a funny feeling that this is where we're going to end up with some duplicates. Plug in 2, I get 32/5 minus 64/3 plus 16 minus. Plug in -2, you get -32/5. You get positive 64/3. Oh, this should have an x on it. So sorry, so that should have been a 32. And this will be a minus 32. And then we distribute this in there, so we're going to have double of everything. So I have 32/5 plus 32/5 is 64/5. Minus 64/3 minus another 64/3 is minus 128/3 plus 64. So that'd take all this times pi over 8, by the way. Wow, that's gross. You know, I'm really tempted. You know what, I'm going to take this times 3 and this times 3 and just put these together first. Because 164 times 3 gets you to 128 and then another one. So that's just going to be plus 64 over 3. So you're going to have 64 over 5 plus 64 over 3. You know what? I'm just going to leave it like that. You could nint it. You're going to get whatever answer that is. That was gross. We probably should have ninted that one, everybody. Sorry about that. But the setup was pretty intense. That was crazy. Now, don't get confused by volume and area, right? Because this is actually back to an easy one. Y equals x squared plus 8 would be up here 8. And you'd have this parabola opening crazy big up here. Y equals 3x squared is something like this. You know what, my guess is they probably intersect right here. And we could double check by setting them equal to each other, right? 3x squared equals x squared plus 8. Subtract x squared. 2x squared equals 8. Divide by 2, x squared equals 4. X equals plus or minus 2. Bam. And if you plug 2 in, you get 12. So these meet at 212 and -212. Now if I erase this work over here, so I figured that's where they met. How do you find area in between curves, right? How do you find this area? This is from section 7.2. This is not from section 7.3. So don't try to do pi r squared or volumes or anything like this. This is literally just the integral from -2 to 2 of the top one minus the bottom one dx. This is so much better to do without int, I think. It's much more likely to be something like this than a crazy volume one like that in your head. Definitely, this one's definitely way better because that was gross. -16/3 plus 16 minus a 16/3 minus 16. If we distribute that, I'm going to have 32 minus 32/3. If I take this times 3 and this times 3, I'm going to get 64/3. And no pi's or anything, right? You're not doing circles, just doing straight that. So just don't forget that we did area before we did volume. So here's another one that this is just a good one to recognize that you're going to have to use like y integration, right, is my guess. Because if it says x equals -1, this is like this, boom. Wow, this thing is a little bit crazy because it's a sideways parabola. You know, I might just plug in 0 for y. I just might plug in some things and see where we're at. If I plug in 0 for y, then I get out -4 for x. Whoa. So that means I'm at -4, 0, like right there. If I plug in 1 for y, where am I at? 1 plus 2 minus 4. So I plug in 1 for y, that's -1. So I'm right here. For x, if I plug in, let's plug in 2 and just make sure that that thing crosses. Doesn't turn around there. 2 would be 4 plus 4 minus 4. So that's -4. So -4, 2. Doesn't make much sense to me that this thing would be opening this way. Not to mention there would be no area enclosed. Should we double check this on Desmos? I feel like I'm doing something wrong. Y squared plus 2y minus 4 equals x. Oh, I gotta change my settings back to not pi. Yeah, I was opening the wrong way somehow here. So I did something wrong. So the thing I just plugged in, 2, oh, 2 should have been 4. Is that what I did wrong? Oh yeah, 8 minus 4 is 4. That's why. Gotcha. So this should be right here. That makes me feel better. So that's right here. No, right here. There we go. And then if I plug in -1 for y, we get 1 minus 2 minus 4, which is -5. So -5, 1. So right there. And this thing starts to turn around. I mean, there's not much of a good way to do this one except for that way. Boom. So here's that. And then we need to do y integration. Whew. So y integration would be this point right here is the point -1, 1. And this point down here is the point -1, -3. But if we're doing y integration, that means we got to look at it sideways and do the integral from -3 to 1, right? So -3 is the y on the bottom, it's shown right here. 1 is the y on the top, and then we do top minus bottom. But if you're looking at it with your head tilted to the right, the line x equals -1 is on top, and subtract out the parabola, which is y squared plus 2y minus 4. And again, we got to use everything with x by itself because which they at least set that up for us. Graphing it was a pain without Desmos, but they at least set that up for us, and then we'd solve this guy. So -3 to 1, -1 minus y squared minus 2y plus 4. We could combine those and get plus 3 dy. And then we could go backwards from there, right? -1/3 y cubed minus y squared plus 3y from -3 to 1. I feel like I'm doing a lot of integrals. I don't know if that's actually helping you guys. If it's not, then you can always skip ahead, I suppose. So plug in 1, you get that, and then you subtract out what you get when you plug in -3. Well, this is nice that we get some whole numbers here. -3 cubed is -27 times -3 is +9. -9, and then -9. So there we go. So we have, I'm going to combine these and combine all these because that's going to be -9, but it turns into a +9. And then we've got -1/3 plus 2 plus 9. So 11 minus 1/3. 10 2/3 happens to be the area of that guy. Boom. And I think this is the last one I got, yeah. So here's one more revolving one for you. So find the solid when rotating the region enclosed by these about the x-axis. That's nice. And then it says afterwards you could try about y equals -1. So let's graph these things first. Y equals √x plus 1 should be this guy, I believe, right? And then y equals x² plus 1 would be this, and it would go like this. I think they're talking about this little guy right here. I might enlarge this a little bit just to help us out here. Let's make this one and this one, etc. So that first one is a root graph that goes up 1. So it's a root graph, and it looks like this. The other one is a parabola, so it starts here and it looks like this. So it's this little guy right here. And we are revolving it about the x-axis, right? So about this way. And if I do my thing that I normally do with drawing kind of reflection down here, is there some open space? For sure. So this is going to be the integral from where are my bounds? 0 to 1, right? Because that's where they meet. Of the, well, it's pi r² minus pi r². The hardest thing is noticing which one was on top, but didn't it do something like this one went on the bottom, right? And then this one went on the top. So the top is actually the √x plus 1. And then the bottom is actually the x² plus 1. This would be your integral. I'm not going to plug that in. That's a nint. It's a good nint question. So that's your integral there. To revolve it about y equals -1. Wow. So let me erase what this stuff is. We revolved this thing in here about y equals -1. That's a little tricky because that's this line right here. So that basically means that you've just got a whole, like it's going to be all the way down here that you revolve it, right? It just got a lot bigger as far as the circumference goes, which means the radius got bigger too, right? So this is tricky, all right? The bounds are still from 0 to 1. We're still going to have pi r² minus a pi r². There's openings in the middle. Still dx, it's still going about kind of something in the x direction. The question is, what is the upper radius now? Because it's the function that we had, but we got to go all the way down here. There's two ways to think about this. You can think about it being the function, which is √x plus 1, which we did put in there last time, but that would only get us to the axis, right? We got to get farther than that. So it's, you can either think of it that as that, and then you're like, oh, I'm adding 1 to the radius because I'm adding this 1 right there. Or you could think of yourself as subtracting off the equation of this line that's going to, but guess what? That's the same as adding 1. So it's √x plus 2 in here. What's that make the inner radius? So the inner radius now has to go from here, but still all the way down to the line, so same thing. It's the x² plus 1 minus a -1 or plus 1, so x² plus 2. And then you could also nint that. Let me know if you guys have any questions, because we will be taking our quiz on this section. And I think it'll be the last thing that non-AP people have part of it where you shouldn't use your calculator. It's on the honor system, of course, though. So you guys being out of school did get a little bit off the hook with that. What can I say? So there you go. But hopefully that helps, and let me know if you guys have any other questions.